All right, with functions, you can add or subtract them, which we've done this already. But basically, you'll be given f of x and g of x, and your job is to add them. So in this case, f of x is 3x plus 5, g of x is x squared. So we have to add f of x to g of x, which there's no like term, so it's just x squared plus 3x plus 5. For the subtraction, because we're doing g of x minus f of x, and f of x has two terms, you have to make sure you distribute that negative. So when we do x squared minus 3x plus 5, we distribute the negative and it turns into x squared minus 3x minus 5. And again, there's no like term, so there's nothing else we can combine. And that would be adding or subtracting functions. We also have multiplying and dividing functions. Now, again, f of x, we're going to let be 3x plus 5, and g of x is going to be x squared. So we might see f of x times g of x. In that case, again, you need to take your f of x, 3x plus 5, and multiply it with your g of x, x squared. Distribute the x squared, and you'll have 3x cubed plus 5x squared. There it is multiplied. Division, in this case, is pretty simple. You might see some more complicated problems in our textbook problems that we're going to do in class. But f of x divided by g of x, here f of x is 3x plus 5, g of x is x squared. There's absolutely nothing we can simplify. There's nothing we can factor to break down and simplify anything. So to do f of x divided by g of x, it's literally just 3x plus 5 divided by x squared. There's nothing to rationalize. There's nothing using property of exponents that we can simplify. All right, composite functions. This is probably the most important thing that I want you to take from this lesson. So g of f of x is read as g of f of x, as I have written there. When you have composite functions, when you have something written like that, you need to evaluate the inner function f of x first, then use your result as the input of the outer function, so g of x. So I want you to actually pause the video and think of what you need to do for f of g of x, and it's read as f of g of x. So hopefully at this point you've already paused it, and you should have gathered that first thing you'd have to do is evaluate g of x, the inner function. You'll get that value, and then you plug that in for the x and f of x, and then use your result as the input of the outer function, so f of x. And then that would be your solution to f of g of x. On the next page, I have examples of this being worked out. All right, so we're going to let f of x equal x minus 2 and g of x equal x squared. And our job is to evaluate, we're going to look at the one on the left, g of f of 5. So again, we do the innermost first, so we're going to do f of 5. And back in chapter 1, we learned how to evaluate functions like this. That just means x equals 5, so plug in 5 for x. So in f of x, we plug in 5 for x, we get 5 minus 2, which is 3. So then we take that value and plug it in for the outer function, which is now g of x. So we plug the 3 in for the x in g of x, and we get 3 squared, and 3 squared is 9. So g of f of x, or in this case, g of f of 5, sorry, that x should be a 5 there. G of f of 5 is 9. So let's evaluate f of g of 5. Again, we do the innermost function first. So we do g of 5, which means plug in 5 for x. 5 squared is 25. So then we take that 25 and plug it in for the outer function, which is f of x. So f of 25 is going to be 25 minus 2, which is 23. So that means f of g of 5 is 23. And that's how you can evaluate a composite function. Okay, there are some other functions you might see. We're going to go back to letting f of x equal 3x plus 5 and g of x equal x squared. You might see something random like find 5 of f of x. What that just means to do is you take your f of x function and you multiply every term of that function by 5. So as you can see there, I have that equals 5 times 3x plus 5. So distribute the 5, you get 15x plus 25. You might see find f of x plus 10. Well, there you take your f of x function, which is 3x plus 5, and then add 10 to it. So you'd have 3x plus 15. Pretty basic concepts in general, adding, subtracting, multiplying functions. Division, like I said, does get a little more complicated, and then composite, which we'll focus on all of that in our textbook problems in class. Thank you and have a nice night.